Hey, Algebra 1, so let's take a look at our Delta Math work for today. If you haven't created your login yet, please follow some of the first videos that go through those examples using the class code that's on Canvas. And we did a few problems the other day. I want to start over with sequences just from the beginning, and just so that we can kind of get a feel for it. Just kind of review. So it says find the common ratio. Remember, when you have sequences, arithmetic and geometric, you have arithmetic, which is more of an adding or subtracting pattern, and geometric is more of a multiplication or division pattern. And the word ratio here suggests, especially with geometric, that we're looking for a number that multiplies negative 13 to give you 117, and that same number multiplies to give you negative 1053. So you can divide the second number and the first number, 117 divided by negative 13, and that gives you negative 9. And so that's the value that if you were to multiply negative 13 by negative 9, it'd give you 117. 117 times negative 9 is negative 1053, and so forth and so forth. Okay, so maybe we'll get one more. Maybe there's an arithmetic problem. It's another geometric. Negative 9 divided by negative 1. See, I'm multiplying everything by 9 here. Negative 1 times 9, negative 9. Negative 9 times 9, negative 81. So I've almost cleared this one. These were all geometric. Negative 40 divided by negative 10. It looks like they're multiplying by positive 4. Okay. Now, this is an example of I can stop 10 out of 10, says you are good to go. But real quick, here's an arithmetic example. These are more where you're subtracting a number. For example, if I was to do 2 minus 5, that would be negative 3, or negative 3 minus 5 would be negative 8. So it'll let you continue to practice these, which I highly suggest if that's something that you are wanting to do to get ready for the test, to kind of bring your grade up. There's no limit to how high you can replace those grades, so know your stuff by the time you take the test. So the other day I had talked about this concept of writing, using an equation to basically find the 59th term or some future term in a sequence. And so I'm going to copy paste all that information over to this side so that we can kind of explore this sequence. And so let's just look at 29, 37, 45. This is an arithmetic sequence that is adding over and over and over. And if you subtract 37 and 29, it looks like you're adding 8 over and over and over to get to the next number. So we call 8 the common difference. And that's the difference between each of these values, and it's positive because you're increasing. So we have a little formula here, and this formula is used when you have an arithmetic sequence and you know the first number. For example, the first number is 9. And that common difference, that's what the variable d represents, and that in this case is 8. And I'm looking for the 59th term, and so basically I want to plug in 59 for the n term and just calculate to see what this all comes out to be. So let's go back to the calculator, and let's see what we get when we do 29. Let's put 29 plus 8 parenthesis 59 minus 1. And so this is going to tell me exactly what that 59th term would be, 493. And that will jump me in that sequence all the way to that particular term. Let's try another one. So the first number is 14, and in this one it seems like it's subtracting 9. 14 minus 9 is 5, and if you were to do 5 minus 9, you'd get negative 4. And they're looking for the 78th term, so let's replace 78 minus 1. Now I really didn't mean to do that all here. I really wanted to do that in the calculator. So I just did a quick copy paste there, Control C and Control V. So it looks like that number is going to be negative 679, and that makes sense because you are dragging all the numbers into the negatives. So really just focus on using that formula that I'm giving you, that first number in the sequence, negative 17 for the next one. It looks like you're adding 4, negative 17, negative 13, negative 9, you're going towards 0. So we want to add 4. And then they want the 75th number. And you want to subtract 1 in the formula because you start at negative 17, you add 4 once to get to negative 13, but that's the second number. So if I'm looking for some number in the future, you don't want to add it on 75 times, you really want to add it on 74 times. That's kind of why the formula works the way that it works. So there's a few of those. Let's go to the nth term of a geometric sequence to see how that one works. So geometric is when your sequence is more based on multiplication. And so the formula will change a little bit. Let me just take all of that away. Let's copy paste the directions over here. And for some reason it's duplicating the very last part of the sequence, so let's erase that. So I want the 12th number in the sequence, and I could just kind of figure out that basically this pattern is multiplying by 2. 4 times 2 is 8, 8 times 2 is 16. So I can kind of go in the future, keep multiplying everything by 2 to find the next number. But this has its own formula, and I am basically going to start with my first number again. That number is 4. And if I figure out the common ratio by using division, 8 divided by 4 is 2. You're multiplying by 2 over and over and over. And now this is an exponent, this 12 minus 1 that I want that raised as an exponent because geometric is more of an exponential concept where you have the variable's exponent being replaced with different numbers. So I'm gonna type that into my calculator here, 4 times 2, and then I wanna raise to the 12 minus 1. Now I really want that 12 minus 1 to all be in the power. So maybe I'll just do 12 minus 1, that's really 11. Okay, so I'll just make it easier on myself. So 8192, and that is the 12th term in this sequence. So I'm just gonna look at my work here, 12 minus 1, 11, that's why I put that power in the way that I did. Let's try another one. So this one's 7, negative 28, 112. Just to get those over here so that we can kind of look at it. So basically this one isn't multiplying by 2. If you were to divide the second number and the first number, this one's actually multiplying by negative 4. So that's going to change some of my information. My first number is 7. I'm multiplying by negative 4 over and over. And they do want the 12th term, or maybe they actually want something, actually they want the 11th term for this one. So we really want to make sure all of the information from the problem is accurate. So what I want to do is go to my calculator and let's type in 7 parenthesis negative 4, and then this a to the b power, that'll raise it to something different. And I think for this one, 11 minus 1, that'll be 10. So let's see what that gives us. Pretty big number here. Just going to copy paste that. I highlighted it, Control C, and then when I click in here, Control V. So let's jump in and look at another one. Write explicit formulas for a sequence. And so this is building them from scratch, and so you probably have some of these on your assessment to see that you understand this process. So it wants us to write an explicit formula, and I want to start by doing the first number in the sequence. It looks like in this sequence we're adding 7 over and over and over, and so then I want the formula n minus 1. Now there's a chance that it wants me to simplify this, so let's see when I submit it if they like it or if they wanted me to distribute in combined like terms. Actually, it took that perfectly fine. It didn't need to be simplified in any way. So let's try another one. This one is more of an exponential function, or a geometric sequence rather. And so that's going to follow that other format where you're starting with the first number, but now you're going to put in parentheses what you're multiplying by. See, this is 20 divided by 5, 4, or 80 divided by 24. You're multiplying by 4 over and over and over. So I want to click on this a to the b and type in n minus 1. That's just part of your formula, and let's see if it likes it. Seems like it does. Maybe do one more problem here. So this is another one that seems to be geometric. It looks like you're multiplying. We're multiplying by -2. 7 times -2 is -14. -14 times -2 is +28. And then we'll use this a to the b to type in n-1, and that gives me my final answer. So just reviewing those two formats that we had for arithmetic and geometric, and knowing those formulas and how they work. So let's go to this last section for sequences. It says the first 3 terms of the sequence are given. What would the 50th term be? So this is kind of that same idea of looking into the future and understanding how to use the formula. And so this is arithmetic. You're adding 6 over and over. So I want to start with the first number is 12. Your common difference is +6, and I'm looking for the 50th number in the sequence. So it looks like that's going to be 306. So let's type that in and check our work. Looks like we got it. So let's try a few of those. So this one seems to be going down. It looks like it's going down 3. And when you don't see that, take the second number, subtract the first number, and that'll tell you, do that in the calculator though. Don't do that in the answer. Put that in the calculator down here. And then that'll show you, oh, the common difference is -3. So then you can say, okay, well, the formula is the first number, the common difference is -3, and I'm looking for the 31st number. So let's do like n-1, but plug in 31 for n, and that gives me 71. So that takes me straight to that final term. Maybe we'll do one more of those because this is geometric right here. Maybe another one if we get a geometric next. This is more based on multiplication. If you were to do 65 divided by 13, you'll see that this is, no, I do not want that as my answer. No, no, no. I wanted that in the calculator. So that is a little tedious. Make sure you click in the calculator down here, and then you start typing, and it'll make sure that you're typing in the calculator portion. So basically, you're multiplying by 5. 13 times 5 is 65. And if you do 65 times 5, that's where you get 325. So I want to use that same geometric model where I say the first number is 13, your common ratio is 5, and then for the exponent, instead of n-1, it wants the 10th term. So 10 minus 1, well, that would just be 9. So I'm having trouble with the order of operations there, so I'm just doing 10 minus 1 in my head, putting in 9, and then it's looking like it's giving me this number. Control copy, control paste, and that'll take me to this really large number in the future. All right, so I think I'll go back in one of the sections that I had not done as much on. Maybe we'll go back and do a few more about this nth term. It's kind of what I was talking about in that particular question. So geometric, I need to know the first number. First number is 8. Based on multiplication, 8 times 4 would be 32. And then it wants me to find the 15th number, so let's raise that to the 15 minus 1, or the 14th power. And that's going to give me this real large number. So I'm going to highlight that, Control C to copy, click in here, Control V to paste, and that just makes things a little simpler so you can check your work. All right, so that wraps up sequences. Hopefully that was helpful. In the next video, we will start talking about solving. We're going to talk about equations and inequalities. And then in the last section, we'll talk about linear systems. And then once you've done all your practice, you'll be ready for your assessment. And hopefully you'll do well enough to bring your grade up based on your grade replacement from your Elastic quiz. Hope you're doing well, hope you're healthy, and I'll talk to you later.